So today we are going to talk about an important topic, concrete mix design. So we are going to see what is mix design, the different grades of concrete, the factors influencing the choice of mix design, the methods of concrete mix design, and a mix design by the method of IS, Indian Standard Method. What is actually a mix design? It's nothing but the process of selecting suitable ingredients of concrete and determining their quantities with the objective of producing a concrete of the required strength, durability, workability, and economically as possible is termed as the concrete mix design. Grade of concrete. The characteristic strength of concrete FCK is defined as the strength of concrete below which not more than 5% of the test result are expected to fall. What is M20? M refers to the word mix. 20 refers to characteristic compressive strength of the cube of dimension 150 mm by 150 mm by 150 mm at the end of 28 days of unit Newton per mm square. So here we can see the different grades of concrete and the particular groups which are there put off and their specified compressive characteristic strength at the end of 28 days. So there are basically two types of mix, nominal mix and the design mix. Nominal mix concrete. The wide use of concrete as construction materials has led to the use of mixes of fixed proportions which ensure adequate strength. These mixes are called nominal mixes. The nominal mix concrete may be used for grades like M5, M7.5, M10, M15 and M20. The proportion of material for nominal mix shall be in accordance with Table 9 of IS 456-2000. So here we can see the different grades of concrete and their mix proportion, that is the proportion of cement, fine aggregate and coarse aggregate. So what are the factors influencing the choice of a mix design? The grade of concrete, the type of cement used, the maximum nominal size of the aggregates, the grading of the combined aggregates, maximum water-cement ratio, the workability, the durability, and at last the quality control. So what are the methods of concrete mix design? IS method, ACI method, Road Note 4 method, IRC 44 method, arbitrary method, maximum density method, DOE, British method. IS method. It consists of the following steps: target pin strength, selection of water cement ratio, determination of water content, calculation of cement content, and at last calculation of mass of fine aggregate and coarse aggregate. First step, to find out the target strength for mix proportioning. F-CK represents target mean strength at 28 days. FCK represents characteristic strength at 28 days. T is equals to tolerance factor is equal to 1.65 according to IS code 10262/2009. S stands for the standard deviation given in the table. So the equation becomes F dash Ck is equal to Fck plus T into S. So here we can see the assumed standard deviation values of different grades of concrete. Next step is the selection of water-cement ratio. Different cements, supplementary cementitious materials, and aggregates of different maximum size, grading, surface texture, shape, and other characteristics may produce concretes of different compressive strength for the same free water cement ratio. Therefore, the relationship between strength and free water cement ratio should preferably be established for the materials actually to be used. So, according to IS 456/2000, in table 5, we can see the different types of exposure and the maximum free water cement ratio. Next step is the water content. So here we can see the nominal maximum size of aggregate and the maximum water content. Next step is the calculation of cementitious material content. The cement and supplementary cementitious material content per unit volume of concrete may be calculated from the free water cement ratio and the quantity of water per unit volume of concrete. Cement content is equal to water content by the water cement ratio. Next step is the estimation of coarse aggregate proportion. So we can see the nominal maximum size of aggregate and the volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate. So the content of fine aggregate is equal to 1 minus the content of coarse aggregate. Next step is the estimation of mix proportion. The volume of cement is equal to mass of cement divided by the specific gravity of cement into 1/1000. The volume of water is equal to mass of water divided by specific gravity of water into 1/1000. Volume of admixture is equal to mass of chemical admixture divided by specific gravity of chemical admixture into 1/1000. Volume of aggregate is equal to 1 minus the volume of cement plus volume of water and volume of the admixture used. The mass of coarse aggregate is equal to VA into volume of coarse aggregate into specific gravity of coarse aggregate into 1000. The mass of fine aggregate is equal to VA into volume of fine aggregate into specific gravity of fine aggregate into 1000.